Awesome. Thanks a lot. Thanks everybody for coming. I hope it's been a nice conference for you so far. So yeah, I'll try to pack in a lot of different topics today. They are a little bit maybe different from your standard talk at the conference about blockchain. So it's very much about AI and knowledge graphs, and of course blockchain. So, but yeah, to briefly introduce myself, I'm one of the founders of OriginTrail, and also the CTO, kind of the designer of the decentralized knowledge graph concept, which I'll explain today. Originally from Serbia, so yeah, we can also later chat in Serbian if you're around. And yeah, I'll introduce something called decentralized RAG, and it's not rug but rag. So we'll talk about that framework today and what it means for the internet really. So I'll just head over. I think I have a bunch of topics to cover. I'll start with what the problem is that we're trying to tackle here. So just as when internet showed up, like it was this amazing revolutionary technology, very quickly also some anomalies showed up. For example, one anomaly we all know about is spam. Like all of a sudden you had this great connectivity feature, everybody could send like an email to anybody, and then it was all nice and great until spam showed up, and then everybody, it was basically the cost of producing messages went like so low that an anomaly showed up. Spam was something nobody wanted or expected. Maybe we could have anticipated it, but long story short, now many decades later, we have email that have spam filters that work to an extent, but actually centralize the architecture. If you are an engineer that ever tried to run your own email server, you know what I mean, because it's a pain in the ass. Basically, you cannot do it. Like no email provider like Gmail or whatever is gonna accept emails from an unknown server, even though email was kind of like originally decentralized, not in the sense that we see decentralization today. So in a way, there's kind of a solution, but I'm sure nobody in this room is happy with the solution being centralization and like capture by big companies. So it's an anomaly that like kind of still is not solved, and that's spam. So what happens with AI? So AI brings more new anomalies that are tricky, and they're actually another threat to the internet, probably even bigger threat than so far. First one, I'm sure you heard of, hallucinations. I won't explain a lot, but basically I'll just explain why, because it's relevant for the story later. Welcome, come on in. We're just starting. So hallucination, that's the thing when you ask like ChatGPT something and it gives you like a response that like is not true. It just like burbles something out. Doesn't have to be ChatGPT. It's a feature rather than a bug of LLMs. And it works like that because, and I'll simplify to the bone here, it's not entirely precisely correct, but basically LLMs, they are kind of like really good statistical guessers. You give it a bunch of words and then it knows what are the best statistically plausible words to come next. So they're guessers, and turns out you can do a lot of stuff with this guessing, but that means also that sometimes they guess wrong very confidently, and that's what we call hallucinations. So like I said, I'm sure you ran into it. You probably, since you're here at the conference, you have kind of at least some notion of ownership in the digital world familiar to you. So like in terms of tokens, in terms of all kinds of cool things we're seeing in Web3, data ownership is becoming even bigger problem with AI, because AI just siphons all the data everywhere, like doesn't care about IP, which was been like a thing that's been happening for a while in Web 2. Again, centralization. Today it becomes like even worse. And for example, you can see artists in the world, they're like basically protesting because of this, for a good reason, because like, you know, imagine being an artist who's been like spending your whole life energy into becoming like an actor, and then they basically use your image to create like you know, new movies with AI without anything that having to do anything with you. And I'm sure everybody's like sort of had a little bit of that thought, like what happens if AI replaces all of us. So in a way, like we can see the image of that actor or actress actually being their data. So that's another problem. Big one is centralization. Like literally, I'm sure I shouldn't pitch or talk about this here. At some other conferences which are more AI conferences, I speak about this problem a bit more. So I'm sure you guys know what this means, but basically somebody taking in all the value, all the control, not a great idea. That's not part of our ethos. Bias is a thing that comes from that to an extent. So that means everybody here has some bias. Nobody is like perfectly neutral, or I have bias. And then Google has bias. You've seen that with Gemini, like creating specifically gender neutral outputs just to try to be more gender neutral when it doesn't even maybe make sense. Like, for example, can a Roman emperor look like, I don't know, somebody from India? Probably not. Nothing against people from India, but it's like, it's kind of a form of bias rather than hallucination because somebody told the LLM do this. And then this is actually probably, I'm not sure, does anybody know about model collapse here? Have you guys heard about this problem before? Okay, there's one person. You want to tell us in your own words, or should I explain it? Exactly. So really well put. Basically, AI generates data all the time. All this new data gets eventually somehow into its input where it learns from that data. And then what turns out to happen is that it becomes worse. It hallucinates more. It basically, and there's kind of a mathematical logic to it, because what AI kind of like LLMs, really more like a branch of AI, are doing is they're fitting a curve to some statistical function that represents the world. And if you produce a bunch of stuff that sort of messes that curve up because it's a bunch of statistical outputs, then of course it's going to try to fit something that's no longer probably a sample of the real world. So model collapse has already been detected with Grok, for example, and it's actually considered to be one of the reasons why LLMs are starting to plateau, which is another opinion. It's still under research, but basically it's a proven thing that model collapse is a problem, and we expect with all these anomalies, we expect that just as with spam, it was very cheap to create new email. It's very cheap to generate new content. So pretty much a lot of the content right now is being created with the help of LLMs, which is not that bad per se, but it's definitely going to influence this problem, the model collapse, and which in a way in our world of Web3, we can consider as content inflation. Nobody likes inflation here, right? So we're all about 21 million Bitcoins, it's never going to change and all these things, or we somehow in governance, we control this. Well, content inflation is real, happening all the time. It's influencing pretty much everything and causing all of these troubles. So what actually I'm going to pitch today is that real content is a new asset class. But yeah, basically, if you're really interested into going deep into this, we recently released a paper. It's a pre-publication. Super welcome to hear your feedback. And that's where we basically talk about this convergence of crypto, internet, and AI. And we call this idea the Verifiable Internet for AI. You can find it on this link. It's about a 10-page document which describes a lot of these concepts that I'm going to show today in much more depth. And yeah, like I said, this is an open idea, still very much open for feedback and contributions. So if you find some ideas, just let me know anywhere, Twitter or whatever channel, Telegram. So I'll dive a little deeper into the content of this paper through the presentation, just so you can see if it's interesting to go deeper. But what basically the point we're looking at here is to get some sort of emerging collective intelligence in a perfect world. This would be something that is free of those anomalies that we mentioned at the beginning, the problems. And we go by the Turing Award winner Jan LeCun's quote, who, even though being very opinionated, maybe if you follow him, you know that he's very, very much in a fight with Elon Musk right now on Twitter. But I think personally, and we as a community, what he said here is really true. So if we want to build a human collective intelligence system that is basically considered to be a knowledge base of the entire world, it has to be crowdsourced. So today I'm going to talk about how we're going to crowdsource it. What we're ideally looking for is some of these characteristics. So this is the dreamland where we want to be. We don't want to have hallucinations. We want to have both data ownership but also information provenance. So where does some information come from? Did I generate it with an LLM? Does it come from like an old school enterprise system? Is it from your phone? That's what we want to know. Ideally, there's knowledge crowdsourced from multiple places. There's an ability to remain private, obviously have some form of data privacy baked in, ownership, like I mentioned at the beginning, and then finally incentives, like so that we break this problem of centralization and rather turn the incentives in the system in such a way that it doesn't cause, like it did with email, as I mentioned at the beginning. How can we make it so that it actually promotes decentralization and more a more fair value exchange, basically? So those are some of the characteristics. If you look at kind of a high-level diagram of this verifiable internet for AI idea, as we present a framework for it, you can basically focus on several different layers. Obviously, there's a bunch of data coming in different models, text, image, video, and all kinds of things. And then there's different techniques to use it with AI, obviously. A lot of these cool things emerging, like graph neural networks, agents. I'm sure you guys heard about that a lot. And but the idea here that we're actually trying to showcase to as many people as possible, because it's really powerful, is this idea of decentralized retrieval augmented generation, or DRAG, like I said at the beginning. So, but basically, just if you can see in those few bullets, what this idea is about is that we have AI operating on verifiable inputs, that it's basically using this framework, retrieval augmented generation. I'll explain why. That it's organized in a decentralized knowledge graph, so that we can do many different things with it, that it's all based on Web3 infrastructure, and the trust root is basically enabled by blockchains, including the incentives, which basically push for positive alignment. So what is RAG? If you haven't seen RAG, I'm sure you use ChatGPT pretty much, or something of that sort. You go, you ask ChatGPT a question like, what is the capital of France? And it says Paris and whatever. And this is like basically an LLM just responding to you directly. But like when it starts to hallucinate, it's probably because you asked a little bit more complicated question than that. Or it doesn't know about something. And usually companies who have some private data, for example, everybody wants to build their own chatbot on top of their data. That's like, literally everybody is doing it. And the way they do it is this thing called RAG. So it's, let's call it conventional, even though it's like super new. Conventional retrieval augmented generation. The idea here is you have some UI and you have like an AI model, but instead of asking an AI model directly, you go and you kind of figure out what data it needs first. For example, you're asking about, I don't know, for example, NVIDIA earnings report. You want to know something from that report. It just came out like last week. Obviously, ChatGPT doesn't know about it, so like it will return some bullshit most likely. But if you fetch that data and you feed it to the model and you say, hey, find the answer, but in that data. Don't like try to hallucinate or figure something else out. Just like, read this and chew it up for me and return it. That's why it's called retrieval augmented generation, because it first does the retrieval in this classic information retrieval sense. If you've been like a computer scientist, probably you know about this branch. It's called information retrieval. It's pretty much all of the search engine work. So basically, that's the same idea here. And then we feed the model, and then we tell the model to do generation, but doesn't do generation from whatever it knows in its weight. We tell it like, use that. And actually it turns out that this minimizes hallucinations quite a bit. You can go into the details very much, so we won't have time for that, but basically it helps with the hallucination problem. Yet again, it doesn't help with all the problems, so like everybody's doing it, like I said, and everybody's doing it in isolation. Like each of the companies, they're doing this on their own. And we're kind of creating like some form of disconnected AI system. So like I said, the big pitch behind OriginTrail is that knowledge is a new asset class. That this stuff here is actually very valuable. And that if we create something called knowledge assets, where we package all this knowledge in certain ways, then we're actually able to solve for all of those anomalies. And what these things contain, actually, a knowledge asset is, by the way, a live thing. You can create a knowledge asset on OriginTrail right now. It contains knowledge in different formats. Normally, usually you would connect some form of symbolic representation, which is graph data, and neural representation, which is vector data. Please go ahead, go ahead. Welcome, you're coming at the right time, because the punchline is now. Yeah, take your spots, guys. How much time do we have, by the way?
10 minutes.
Oh, beautiful. I have enough time. But with questions, I'll speed up then. So basically, you can literally go to the docs and read much more about this if you're interested. But the point I want you to take from here is that the knowledge can sit in any system. As long as we wrap it in an NFT and provide the according proofs on chain, we're able to verify even private knowledge, but especially public knowledge. And that's why the DKG, the Decentralized Knowledge Graph, is here. But before I explain the Decentralized Knowledge Graph, can anybody tell me, but you have to be really quick because we don't have time, like a common thread under the hood of all these here? Like, do you know, like, what's their superpower? Some of you have heard this before the talk because we were having lunch together. Actually, all of them have knowledge graphs under the hood. So that means whenever you go to Amazon, you want to buy something, and Amazon recommends you something else to buy based on your history, that comes from knowledge graph. Netflix recommends you a TV show to watch based on your history, comes from a knowledge graph. They find similar people who watch things like you and they recommend something. Facebook with their posts, they basically try to keep you more engaged so you're there on the platform. Come again? Yeah, basically target market. Point being is, if you're on Facebook and if you're not paying Facebook, that means you're the product. They want to keep you there longer and longer because that creates value for them. And the point here is that they all get a ton of value from putting their knowledge, or rather data, into knowledge form. And there's a distinction between data and knowledge. Data is very raw. Knowledge is more like something you would feed to an AI. You probably heard of things like annotation. There's people who are annotating images, like what's on an image, so you can train AI, things like that. Well, basically, knowledge is this higher order than data. It's much more contextualized, less raw, and much more connected. So they use it, and they generate a ton of value, but they all have closed knowledge graphs. You can basically only access kind of something from the Google knowledge graph, and the reason for that is because their key product is search. And it's basically public, so you're able to access. So what we're doing at OriginTrail is we're creating a decentralized knowledge graph, or DKG. The architecture is, in the most simplified form, looks like this. It's a two-layer system, a blockchain layer that supports multiple blockchains. And by the way, we're just also expanding it to more blockchains as we speak. Base is the next one that's coming up. It's a separate data network that actually hosts a bunch of these knowledge graphs. You can run a node on your own. And it hosts these knowledge assets. So the data sits here, the vectors, the knowledge graphs, the NFTs, the proofs and tokens sit here. So we don't overload or bloat the state here and use the chain for what it's not made for. It's not made really as a database for data querying. Rather, we use databases that were made for that here. And then you can build, obviously, all kinds of AI apps on top. But the point here being is that the best kind of way to do it is with this decentralized retrieval augmented generation framework. But ultimately, there's this problem of incentives that I mentioned, right? So there is a reason why all of these companies build centralized knowledge graphs. And the idea of knowledge graphs comes from, and some of you maybe heard of it before, Tim Berners-Lee, the guy who invented the World Wide Web. He called it the semantic web, a web of data. It was this utopian idea where we connect, just like we connect all websites via links, we connect all the data on the internet via some form of new links. And it's considered kind of like an idea that never really took off. My opinion is it did, but it did in a centralized way. So all of these companies, they had the resources and knowledge to do such a complex thing. And they got a ton of value. But the incentive was there. They knew how to use it. So what if we give incentives in Web3 way? We have Web3 today. It couldn't have happened before Web3 even existed, because even if you look at the architecture that this famous inventor of World Wide Web proposed, is that trust was an element that they kind of added on top at the end. And I would argue it's literally at the bottom. It's a fundamental element. So the idea of these incentives, I'll explain in a moment, is that we really provide token incentives to anybody who wants to contribute to such a global knowledge base and really crowdsource it. So DRAG is this decentralized retrieval augmented generation. What it really does, it combines these neural AI elements, LLMs, and symbolic AI elements, which are knowledge graphs. They're a branch of AI called symbolic AI with decentralized technologies. So essentially LLMs plus knowledge graphs plus decentralized identity plus incentives tokenization, basically on anything you want to build on the blockchain. So you can consider it kind of like this. So the DKG is where the knowledge assets live, and they live organized in paranets. These paranets are kind of like, in the world of blockchains, you can consider them like rollups, because they're like different types of things. They have different characteristics, but they're not exactly the same. They're not like just connected through one single chain together. They're more of a kind of like, let's say, different tables in your database, but it's in the same database, so you can query from different tables easily. And an example of a paranet is, I'm going to show in a moment, but basically a paranet is something operated by a paranet operator. You can start a paranet. We're literally launching this feature next week on mainnet. And the idea is you can pick a topic, let's say Ethereum, and you can create a knowledge graph, a decentralized knowledge graph based on knowledge assets you and your community populate. You can create the AI services on top. They can be both on-chain or off-chain. And you can ask for incentives. Who gives these incentives? Well, the incentives come from a custom chain that the OriginTrail community spawned called NeuroWeb. And this NeuroWeb has this Neuro token. So this process is actually called knowledge mining. If you add new knowledge to the network rewards you with tokens. Just like if you, let's say, add hash power to the Bitcoin network, Bitcoin rewards you with Bitcoins. Here, the idea is that you get tokens in return for some useful knowledge. Who determines what's the useful knowledge? The paranet operator. So this blockchain, this NeuroWeb network, basically that's its key feature, that it is an EVM-enabled blockchain. It enables all kinds of cool things we're used to, but like the core value of it is that it provides neuro incentives for anybody who wants to pitch in knowledge assets that are valuable. Who decides what's valuable? Well, the community, which is, by the way, 100% the organizer and governor of this chain, because it has on-chain governance as well. An example of an IPO that is actually happening right now is by a team called ID Theory. Maybe you've heard of them. They're very interested in DeSci. So what they want to do is basically they want to collect a bunch of knowledge from research papers from many years in history, also developed in specific ontologies, and they want to enable AI agents to produce new knowledge or new discoveries where they, as a DAO, maintain ownership through IP on-chain via these knowledge assets. Lots of more details to that, but I see a nod over there, so I'm going to have to finish, but I promise I'm at the last slide. So that was a lot to cover. I'm going to try to summarize. How can you join the party? So you can basically plug your components. If you're a builder, you can plug into this idea. You can use it on the chain that you're on, or like a new chain that we can also integrate. We're happy to talk about that. You can build decentralized AI solutions with DRAG. We have an inception program where we can also support you through something called deliberately ChatDKG. So I encourage you going to this website, checking it out if you're looking to build something in this area and see actually how DRAG works. So there's a live application built on DRAG, actually running on Polkadot and Ethereum at the same time that you can test. And you can launch your own IPO, pick a topic, and like basically get a bunch of incentives from the community. Finally, you can, all of this is open permissionless infrastructure, so you can run it yourself. So you can run the nodes of the DKG, you can run nodes of NeuroWeb, you can stake, you can contribute to code. So there's a bunch of ways, if this idea seems remotely interesting, for you to be part of it. Super happy to talk about that as well later. I know that we're out of time. I'm just not sure if we're out of time for questions also.
So I think we can have one quick question.
One quick question.
But quick.
There is one, yes.
Here you go.
Yeah, thank you for the talk. So with the knowledge, the thing is, for instance, if I'm building a model and I need to train it on your data, right? But I need actually it only once, right? How would you like, I don't know, kind of continue supporting this incentivization, like keeping this knowledge actually constantly required by your users, right? So actually to keep it like, I don't know, kind of fresh, right? Because for instance, if I just like collect data, I can like, I don't know, pay once, download everything, and actually, yeah, now I get back to you. So.
Yeah, it's a bit of a longer question. I'll try to rephrase the way I understood it. So basically, the question is, you, let's say, as a data buyer, somebody who's interested in the data, you'd say, I'm interested in this. What happens once you download it once, and why would somebody keep contributing? Okay, it's there's two scenarios here. One scenario is us crowdsourcing knowledge into one shared, reusable knowledge base. And for that, the Neuro token is there to incentivize people. You can decide what kind of quality metrics, let's say, for knowledge you want to embed in the system. And that's the crowdsourcing part. And this basically makes most sense for crowdsourcing public knowledge. What I sense in the question is another case, which is knowledge marketplace features. So the ability where you can come and buy some knowledge, which is also enabled and comes on top. So imagine, obviously, if you're doing some knowledge marketplace, you're doing that with something which is more like private data. It's not going to be public because somebody can just download it and doesn't have to pay for it, right? So the idea here is that if, let's say, you find a case where there's a bunch of private data that people normally won't share. I'll give an example. Let's say wearables. I don't want everybody to know my bodily functions all the time. But maybe you're a buyer for like a crowdsourced amount of data, like thousands of people giving you this data in an anonymized way. A PairNet could help people upload their data in an anonymized way. The public part of the data is actually the part that enables discoverability. So when you query the graph, you find, there's 5,000 entries for, heart rate, whatever. And then that's what gets incentivized with Neuro. Then when you click buy, when you purchase that data, then essentially transaction happens on chain. And that's the second step to it. So I hope that gives you a bit of a better answer. And I apologize that we took so long.
It's perfect timing. Perfect
Awesome.
timing. Thank you so much. This was
Thanks,
amazing.
everybody.
Thank you.
Thank you.